Good afternoon, good morning, wherever you are. My name is Karl Wagner. I'm the Managing Director of the Global Rewilding Alliance, and I welcome you to this webinar. In the name of the hosts, which is the Yale School of Environment, the World Maritime University, Rewild, Rewilding Europe, WWF Netherlands, WWF EPO, EFO, and the Global Rewilding Alliance. The aim of this webinar is to present the new science and the evidence that shows how wild animals play an important part in increasing the capacity of ecosystems to capture and store carbon. We name this science Animating the Carbon Cycle, or in short, ACC. As we will see, wild animals are more than meets their eyes. They are the managers of the ecosystems, and they are control elements of the carbon cycle in an ecosystem. The restoration of nature and the comeback of wildlife is a powerful approach to, at the same time, simultaneously address the two main crises of humankind: biodiversity extinction and climate change. It is also maybe the most cost-effective way to draw down old carbon from the atmosphere, as Professor Oswald Schmitz will explain. I hope that through this webinar, the argumentation that we present will become part and parcel of the debate for the restoration of Europe's nature. We will also show how governments benefit from the ACC approach in reaching the climate and the biodiversity targets and the NDCs. Of course, this requires a bit of a change of thinking. For many, many years, we have more or less rolled over nature. We focused on the exploitation of single commodities, and we have to learn, we have to see and treat the nature now as a partner and look at it in a much more systemic way. Forests are more than the wood that we exploit. Oceans are more than the tons of fish that we catch. And in the end, natural resources, they are renewable, but they are not unlimited. A few words about rewilding and the Global Rewilding Alliance, in case you're not familiar with it. Just to start out with, rewilding and restoring, there is no real clear line between the two. As we say, rewilding is the gold standard for restoration. Not all that is restoring is also rewilding, but all that is rewilding is restoring. So the focus of rewilding is to make ecosystems functional again. And that's important for humankind, because a functional ecosystem is capable of delivering a maximum of ecosystem services on which the survival, the well-being, and the prosperity of humanity depends. If we lose ecosystem services, then this will create costs. And somebody will have to pay those costs. And it's usually the public, which means the citizen or the taxpayer. And what it means is, in the end, it's another bill that ends up on the kitchen table of every one of us. So how do we do rewilding? This varies from place to place, from ecosystem to ecosystem, but includes the restoration of food chains, the reintroduction of key species that are important elements of a specific ecosystem. It includes giving nature the space to develop, which means using non-management as a management tools. It also includes sort of fighting invasive species and so on. What is common for all rewilding initiatives, however, is that you cannot rewild the garden of your neighbor without the permission of your neighbor. So there's always a mandate. And it always involves local communities, because if you do not involve the people living on and off the land, you won't be able to achieve restoration targets. The Global Rewilding Alliance itself has about 200 members, many of them networks in their own right. We actually have quite a backlog of applications, which shows that there is an emerging movement. Our members rewild currently 2 million square kilometers terrestrial and 5 million square kilometers marine. And the role of the Global Rewilding Alliance is to foster this movement by providing a science, communications, advocacy, networking platform, and by empowering all our members to be part of shaping this global rewilding movement. Thank you for your attention for this short introduction. I will now move on. Our first speaker is Fabienne Lemon, the Senior Biodiversity Officer of the WWF EPO, and she will give us an outlook on the latest trends for biodiversity in a EU policy context. Over to you, Sabine.
Hi. Good afternoon, everyone. It took a while because the host had to unmute myself. Also from my part, welcome to this webinar, and I will give you a very quick outlook on the latest trends for biodiversity and some more on the EU policy context. Next slide, please. Last week, the Living Planet report was published by WWF International, which is measuring nature's decline with the Living Planet Index, which is tracking the size of animal populations and how they have changed from the 70s until 2020. And this Living Planet Index is an early warning indicator for extinction risks and helps us understand the health of ecosystems. Next slide. I think you all know that the news is not good. There has been a 73% of decline in the average size of the monitored wildlife populations in just over 50 years. Yes, next slide. So the Living Planet Index shows that the main threat to the wildlife populations globally is habitat loss and degradation, and this is primarily caused by our food system. And the other main threats are overexploitation, invasive species, diseases, also climate change and pollution. And this global index is an average of 3 indices that cover the different ecosystems, terrestrial, marine, and freshwater. And it's actually the freshwater populations that have suffered the heaviest declines. They have been declining with 85%. Next slide. The Living Planet report is now also containing information on the early warning signs on global tipping points that are approaching. And there are 6 global tipping points described. And I'm just going to give one example about the Amazon tipping points, which is very clear, I think, because of course, because the ongoing deforestation results in less transpiration by the trees, which leads to less cloud formation, less rain, a more degraded ecosystem, and then of course more release of carbon dioxide. And I think you all saw in September the media reports about the very frequent fires that we had in the Amazon region. And at a certain point, this change becomes self-perpetuating, and then you have a tipping point. And it's, of course, then not only a local or regional problem, but it becomes a problem for the whole ecosystem. Next slide. The good news is that we can still avoid these tipping points, and we still can have an opportunity, but to achieve this, the next 5 years are crucial. I don't think this is new information. Science has been clear for several years, saying that we have a window of opportunity until 2030 to really address climate change and nature loss. But of course, the window of opportunity is becoming smaller and smaller. The window is slowly closing, and we need to act urgently. Next slide. This means that we need to not only scale up conservation work, but we also need to address the drivers of nature loss. And this means we need to transform the food system, the energy system, and the finance system. And the Living Planet report contains a whole chapter outlining how this can be done. Next slide. Now looking at nature in Europe, excuse me, There, the Living Planet Index shows a 35% decline. This might seem not so big, but of course in Europe, the big nature loss has happened before 1970. Next slide. And given the state of nature in the EU report, the last one from 2020, I think it's very clear that our European nature is not in a good state. For instance, the habitats that are listed under the Habitats Directive, 81% are in poor or bad state. That's really a lot. But also our species and birds are not in good condition in Europe. Next slide. So what do we need then at EU level? Of course, at the global level, and the EU is also party to this and needs to implement it, we have the Global Biodiversity Framework, we have the climate agreements, we have the Sustainable Development Goals, but in Europe we have the EU Green Deal. And it's really important that this EU Green Deal is implemented and enforced fully. So this means no delays in implementation and no simplification that would lead to deregulation. And of course, I'm saying this because as Brussels-based NGOs, we are quite concerned that this window of opportunity of the coming next 5 years is running in parallel with the European Parliament that has become a more conservative European Parliament and a new Commission which might be less inclined in implementing the EU Green Deal. And we saw just now the deforestation regulation, which has been proposed to be delayed for the implementation. And this is, of course, very cynical when we are thinking about this potential tipping point like in the Amazon that I was explaining earlier. So we really need to implement the key nature legislation, the Water Framework Directive, the Marine Strategy Framework Directive, the Birds and Habitats Directive, and the Deforestation Regulation. We need to fundamentally reform the foundations of the Common Agricultural Policy. We need to close the funding gap for nature and redirect harmful subsidies. And we need dedicated nature funding in the next multi-annual financial framework, also to be able to support farmers, fishers, and foresters in this transition that is needed. Next slide. To conclude, I wanted to draw your attention to the importance of the nature restoration law as a key pillar of the biodiversity part of the EU Green Deal. It entered into force in August of this year after a long and heated debate. And of course, now is the time to turn into implementation. It's very clear that by restoring natural habitats like peatlands, this will contribute to climate mitigation. But the fact that also species protection and species restoration can play a role in climate mitigation is much less known. So that's why we are very happy as WWF to be able to co-host this webinar this afternoon, because I think it will give us additional and much needed arguments why in Europe we need to really focus on protecting and restoring nature. So I'm very much looking forward to the next speakers and to the interesting session this afternoon. Thank you.
Thank you, Sabine. This was very enlightening, but also very sad. It sounds like we are, in fact, talking about reanimating the carbon cycle. I want to introduce now our next speaker, Professor Oswald Schmitz from the Yale School of Environment. Os is a pioneer in the science of animating the carbon cycle, and he and his team work on the cutting edge of science in Yale. Os will introduce us to the science of animating the carbon cycle and its practical application. Os, the floor is yours.
good morning or afternoon, wherever you are on this planet. Thank you for spending some time listening to this webinar. I'm going to talk about the fundamental science behind the idea of animating the carbon cycle. And again, as many speakers have already said, this is an idea that is intended to expand the portfolio of solutions that policymakers can use to simultaneously mitigate climate change and the biodiversity loss together. So next slide, please. So to set the stage, though, for what we're trying to address, just think about this graph here. About 275 years ago, in 1750, was the sort of start of the Industrial Revolution. And that's when we started to carbonize our economy. And that led to CO2 emissions from fossil fuel burning, so we could drive industrial production. And that necessarily led to a buildup of atmospheric CO2. Now, the IPCC is really working hard to get us to net zero emissions to prevent more buildup. And the idea behind net zero emissions is that we would switch to green energy technology and renewable energy and wean ourselves off of CO2 or greenhouse gas emitting energy sources. Next slide, please. The problem is that reaching net zero emissions isn't going to be enough. We'll still blow through 2 degrees C of planetary warming because there's still 500 gigatons or 500 billion tons of CO2 sitting in the atmosphere that would be a legacy of the start of the Industrial Revolution. Next slide, please. So what we really need is also, in addition to net zero emissions, net negative CO2 emissions to draw those 500 gigatons out of the atmosphere. So what we're proposing here is not an offset program. It's actually a program to increase the sink strength of the planet to reduce atmospheric CO2 emissions. We're not offsetting current emissions. Next slide, please. If we do that, and if we're successful at it, we have a hope of preventing the planet from warming above 2 degrees Celsius, and maybe if we're ambitious enough, even prevent the planet from warming above 1.5 degrees Celsius. Next slide, please. So one way to do that is to think about nature. Nature already takes up CO2 from the atmosphere and stores it on the planet through, as we've heard, forests take up CO2 through photosynthesis, stored in biomass, stored in soils. And so we're really trying to look at nature as another solution, but how do we enhance nature's capacity to take up more CO2? Next slide, please. So people have proposed nature-based climate solutions, and there are two components of nature-based climate solutions. One is avoided emissions, and the other is enhanced sinks. So we need to avoid further emissions, and what we do in the majority of it is protecting what we already have, right? So we don't want to additionally destroy more nature and release more CO2, which would conflict with reaching net zero 2 emissions, but it would also undermine our ability to increase the sink strength of the planet. So through protecting natural lands and doing a little bit of work on working lands, it's estimated that we can sort of protect 5 gigatons of CO2 from being released every year. And then with the enhanced sink strength through management of lands and restoration of forests and wetlands, it's estimated that we can get an additional 5 gigatons of CO2, additional sink strength. Next slide, please. But if we're going to implement nature-based climate solutions, we need to start now. As Sabine said, we need to get going. We need to do it now. And if we do it between now and 2100, within a 75-year time horizon, we'll need to suck out 6 to 7 gigatons of CO2 per year on average using nature-based climate solutions. Next slide, please. Uh-oh, it ended. So anyway, what we're trying to do is propose a way where we can sort of think about using additional factors to enhance, the sink strength. Now, if you really look at what's proposed now and look at the green circle, right? I said we need to enhance, or what nature-based climate solutions currently propose is that they can get us 5 gigatons. We're going to have a 1 to 2 gigaton shortfall if it's 6 to 7 that we need a year on average. Next slide, please. So, you know, the only animal you see in that figure in the background is cattle, livestock. What about wild animals, right? Could we manage wild animals to do something and make up that shortfall? And what I'm going to talk about now is, yes, we can, and and there are ways of really making some significant gains. Next slide, please. So wild animals haven't been considered largely because of a classic ecosystem paradigm in science, as well as in conservation, where it's viewed that, you know, the biomass of vegetation on the planet is orders of magnitude higher than the biomass of herbivores on the planet that eat the vegetation. And it's even an order of magnitude lower for large carnivores that eat the herbivores. And the same can be said for soil storage. You know, it's orders of magnitude higher than the vegetation on the planet. And so because animals tend to be rare in terms of biomass or numbers on the planet, people have assumed that, you know, they can't hold enough carbon in their bodies. And so, you know, they're going to have a very minimal effect on the global carbon cycle, and therefore it's safe to ignore them. But what they're missing is that the animals can have feedback effects on those big reservoirs, those big components of the ecosystem, both plants and soil, or sediments in oceans. And those negative feedback effects can be disproportionately larger than what you would expect on the basis of their abundance. And this is because animals are linked together in this grand system called a food web. Next slide, please. The way animals are going to be able to do this is through some common mechanisms. They can do it through their foraging. They eat vegetation, obviously. They deposit nutrients in their urine and dung. They can disturb things and actually fundamentally change the biophysical properties of the ecosystem that can actually be conducive to storing carbon. They, you know, in their own bodies, they have organic carbon deposition as well. And in terrestrial systems, they also disperse seeds that actually enhance the germination and production of vegetation. And these mechanisms are true for anything all the way from, you know, tundra ecosystems all the way to the deep ocean. These are a common set of few mechanisms, but they're manifest in different ways depending on the species that we're looking at. Next slide, please. What we did was some synthesis work to figure out how much contribution animals might make to the global carbon budget. So these data are data for what animals can do above and beyond what the ecosystem does without them. That is, what we needed was a control condition without animals, and then a condition where the animals were present. And this is the net difference between the control and what the animals do. And these are measured in ecosystems. People have measured these things in ecosystems, and we've scaled them up. And as you can see, if you protect wildebeest, this is for avoided emission, protect wolves in the boreal forest, protect sea otters on the western coast of North America, protecting marine fisheries, especially the mesopelagic fisheries, which is the bulk of the marine, we get another 5.8 gigatons of avoided emissions. And that's not even accounted for right now in nature-based solutions at all. You know, so some of these animals may actually be supporting what people have calculated only implicitly, because they haven't addressed what the animals are doing, but it's a huge number, as you can see. Next slide, please. We can also enhance the sinks. If we, you know, here's just the tip of the iceberg. If you think about it, forced elephants in the Congo Basin, or restoring bison to some of the parts of the North American prairie, beaver throughout the boreal and northern Europe, sperm whales and baleen whales in the Southern Ocean. That gives us almost another gigaton. So we just these animals alone almost get us 1 gigaton additionality to enhance the sink capacity. So, you know, this sort of suggests there's a lot more opportunity to think about animal conservation as a way of also mitigating climate change. Next slide, please. So what we need is really a change in mindset about the role of animals. Usually animals and biodiversity in general, we usually think of them as stuck on a climate ship, an ill-fated voyage that's going to, damage wildlife and biodiversity. But the idea of animating the carbon cycle actually sees this as animals as being important drivers of the climate ship. So biodiversity conservation through trophic rewilding may be able to help fix the climate change problem. Next slide, please. The issue confronting us right now is that we need to guide conservation and maybe try and identify areas on the planet where we have the best opportunity to do that. Next slide, please. But the scientific information isn't necessarily there. These are the mapped, sort of roughly mapped data, for the animals that I just presented in the table. This is where they're located on the planet. This is where they could have an impact. But a lot of the planet still remains empty. The problem is we don't have the measurements, the scientific measurements to fill in that chart. So what we need to do is actually do some calculations and best estimates. And to do that, we can do it through a modeling effort, and we can calibrate models to the real world. Next slide, please. And to that end, what we have done is actually built a new carbon cycle model where you're looking at, plants and soils, the classic carbon cycle, which includes photosynthesis, plant respiration, plant nutrient recycling, and everything. But we've embedded animals into that and embedded their feedback effects importantly, right? And so we're accounting for the feedback effects that the animals are providing. And our aim then is, next slide, please, is to really start modeling different animal species across the globe. And you'll hear a case study later by Maheen on the European bison. But what we want to do is expand the number of animal species that we consider. And this is just the animals that we've identified as high potential species already for which we can already get some decent data from the scientific literature. But we really want to do a concerted effort to fill in the planet and identify important hotspots. So thank you for your time, and I'll wait answering questions.
Thank you, Oz, for this comprehensive presentation. And that's a good time to mention that the Global Rewilding Alliance this week launched a website that's dedicated to animating the carbon cycle. You have to go to the link animatingcarbon.earth, animatingcarbon.earth. There you will find all the information about ACC, and it's going to be regularly updated when new data come in. The next speaker, Fabio Bersaghi, will talk about the marine environment. He comes from the World Maritime University, and we'll talk about the ocean as the by far most important ecosystem for storing carbon. The buffering capacity of oceans have actually saved us so far from catastrophic climate change, but for how much longer can the oceans deliver this kind of service? Dr. Fabio will talk about challenges and opportunities for safeguarding and restoring the ocean biological carbon pump. Fabio, the floor is yours.
Thanks for joining, and thanks for the previous speakers because are making my job a little bit easier because they already set the context pretty well. I'm a senior scientist at the World Maritime University. In case you don't know us, we are part of the International Maritime Organization. We work a lot at interface between policy and science. So I'll tell you, let's move to the marine world. I'll tell you about the ocean biological carbon pump, how important it is, and what are some challenges and opportunities in connection to animating the carbon cycle, improving financing the conservation, and also releasing helping countries that are quite important into this for the biological carbon pump. So just in case if you don't know what the carbon pump is a process driven by marine organisms, so from phytoplankton to whales, that allows the ocean to capture CO2 and store it in the ocean for a certain amount of years that could go from decades to hundreds of years. Here's just a very quick schematics that this happens through various processes that I will mention shortly. The issue is that marine human activities that are building up and have been building up for the last few decades in the ocean could harm these animals and also diminish the importance of the carbon pump and it's the way it functions. So anything from deep sea mining, fishing, dredging, drilling could affect and have been shown to affect the biological carbon pump. Next. So just to give you an idea, and this goes along with what Oz is saying, is that we need to know the contribution of animals to these processes. And in this case, in the marine world, there has been some science recently has produced some estimates of these different groups. So from zooplankton to these larger fish, jellyfish and so on. So we are building our knowledge more and more out through these different processes from deadfall. So when animals die in the ocean, they fall into the bottom where their body are stored for long term and they don't go back as after they decomposed, their carbon doesn't go back to the atmosphere, to fecal pellets, respiration. So there's all these processes connected to these organisms. Next. And as I mentioned previously, human activities are damaging this ecosystem service, and there's been a lot of research showing that fishing is actually diminishing the capacity of the carbon pump and is creating emissions, not just from the fishing itself, but when you remove fish, those fish are not sinking to the bottom, for example, and not contributing to this carbon pump, and so those are also emissions that are increased indirectly through fishing. And then again, this it's really changes a lot if we look at most of it is the industrial fishing, actually, and artisanal fishing. So things that are really on a large scales where we fished millions of tons of fish each year. Next, please. And this again, we also need to look at the geopolitical of these ecosystem services, the management. I will get that into this detail in the following slides. But essentially, fish are distributed in a certain way in the ocean, but the extraction of this resource is not evenly distributed. So there's these dynamics that are quite important because we need to decide who and where and how we are managing and protecting this resource. Next. So what we did in our last study, we have produced this global distribution of biological carbon pump. And the important thing in any carbon offsetting scheme, or when we talk about carbon sequestration, is figuring out how long does that carbon stay stored in the ecosystem, right? This is very important in carbon offset markets, but it's also when we create any kind of activity that enhances the sink of a particular ecosystem, because carbon at some point will return to the atmosphere. So what we did, which was important, is that we looked at the biological carbon pump and we determined the areas where carbon stays for at least 50 years in the ocean. So each year, the biological carbon pump, next, please, adds to the ocean 2.8 gigatons of carbon. That's about almost 10 billion tons of CO2. It's about 1/4, 25% of CO2 emissions from fossil fuel yearly. So again, this is huge, right? It's a huge percentage of our emissions. This is what the biological carbon pump, it's an estimate, of course, that there's a wide range, but we have determined where this ecosystem process is happening. Next. And this is important because, as Oz mentioned, I will just glance over this, but these the contribution of ecosystem services and of carbon sequestration of animals is there's very little integration in climate and biodiversity policy. If you look at all these international fora, you will see very little mention. The last one that's been developed and agreed upon is the biodiversity beyond national jurisdictions treaty, which finally mentions the importance of biodiversity to also enhance and help in carbon sequestration. So that's the first step. But if you look at the climate COP, there's no mention of animals anywhere. So there's a disconnect now between the science, which has produced a lot of evidence, and this policy. Next. So so the first step, as Oswald mentioned, is important to do an accounting, know where, how, which species are contributing, and next. And so this accounting is important, right? A business would know how many assets it owns. A household would know how many eggs or as in its basket, or how much money in their bank account. And we need to do the same. Next. But the other important part is that with maps such as the ones we have produced, we can actually look at the management and political part of it. So I mentioned globally, the biological carbon pump adds 2.8 billion tons of carbon each year. But how is this distributed? And we see that more than half is in areas beyond national jurisdiction. So these areas, we need to work together internationally and find ways to protect or enhance this service. But then, like, a large part is also in exclusive economic zones, so within national waters. And in that sense, countries on their own can take action and are responsible for this service. And then we see that very little is in MPAs, in marine protected areas. So the protection from legal point of view is very low. Next. And then I mentioned, I already mentioned that this allows to see which countries hold a large part of it, and how little this service is protected within MPAs. But that's just one part, because there's countries that are very large areas of ocean, others small. So if we look at the details next of how this service, especially if we want to prioritize conservation, and again, this was already said, we need to know where should we go first. You might have heard about the 30 by 30 initiative, protecting 30% of the world by 2030. Well, that's when we have this information from science, we can figure out where should we go first. Here we have two targets, 30%, but a more realistic target is 10% in the purple areas. And in that sense, if we protect 10% of these areas, we already covered 30% of global sequestration from the biological carbon pump. Next. So now the question is, how are we paying for this? It's extremely expensive conservation, helping local community to transition to a different type of economy. Financing biodiversity conservation is estimated at $1 trillion per year. On the other hand, we have a service that it's useful for humanity, and a global offset market that's been in 2022 has generated $900 billion. But there's trade-offs we need to consider. If we don't fish, we have less revenue from fishing, but we have a carbon sequestration service that's useful for the world. Next. So here, if we try to see a potential value of this service, and again, this is just potential, because we hope that the biological carbon pump will never go completely away. But in any case, this ecosystem service generates several billions per year in exclusive economic zones and in areas beyond natural jurisdictions. So anything that we can do to enhance the service could potentially generate carbon offsets that are used to pay for conservation and are used to pay local communities, etc. Next. And this is especially important for lower middle income countries, because if you look here at the percentage of this value of this ecosystem service in relation to GDP, we see that for some countries that have debt, they have to pay for climate change mitigation, have transitioned into a different economy, and have to have this service, which is really important for the world, but they need to be able to protect it, right? So next, if we see these 8 countries are the largest, one of the largest, within the top 10 contributors in terms of biological carbon pump. But as we can see, they're indebted. They cannot borrow to deal with all these issues with climate change. They have to make decisions. Do we harm these nature, or do we protect it? But let's be realistic. They need money to make these difficult decisions. Next. So there are some challenges, of course, because integrating in carbon offset market value of the BPC, the biological carbon pump service, is at the moment potential, because there are certain things that need to be in place in carbon crediting schemes. One is measuring the baseline. That's what science does. Measuring the additionality, so what can come extra as we do something about it. And then there's how long carbon stays, and then what if something happens and that carbon is released again in the atmosphere, and of course the co-benefits. So here what I've showed you, the science that we produced, gives us the baseline and permanence, so the 50 years. It will stay there for at least 50 years, but we need still the rest. Next. So I'm finishing up. The other way is that there's not just to finance conservation, there's not just the carbon offsetting market, because it's also conservation in other ways, but there's things such as blue bonds, ecosystem service insurance, and other alternative financial mechanisms that are being deployed actually on the ground. Next. And then again, there's other ways to do this, so to finance conservation. One is changing harmful subsidies. We know that fishing subsidies are huge and have a huge impact in terms of biodiversity and emissions. Another one is taxation. Another one is debt relief schemes. As I showed, many of these countries are actually highly indebted, but they cannot borrow to do anything about climate change or to protect their nature. Next. So I'm just gonna skip this. There's different, but there's no time, and I'm coming to the end. They're just saying this is if you're interested in this research, it should be published soon, but this is the preprint on the QR code. And I'm just finishing saying that, we need to create a more equitable climate finance in international agreements. This is important for mitigation adaptation. We need to map and have an accounting of these services. And this is important to create priority areas for conservation, to know who, where, and how we can manage these important services. Thank you.
Thank you, Fabio. We now want to present an example of how wild animals draw down carbon and the quantities we are talking about. The WWF Netherlands has been a partner in getting the model off the ground, and Maheen Khan from the WWF Netherlands will present a case study on the reintroduction of European bisons in the Carpathian Mountains. This is a project that's been organized and funded through Rewilding Europe, WWF Netherlands, and WWF Romania. Over to you, Maheen.
Thank you, Carl. I'll wait for the slides to come up. Hi, everyone. Good afternoon. I hope you can hear me clearly. Thanks, Peter. I wanted to say quite a few things which has already been covered by the previous presentations, which give quite a bit of strong foundation of what I'm about to say, both in terms of policy and practice a little bit. So as Sabine mentioned in the very beginning of this webinar, is that over the past 50 years, the average size of monitored wildlife populations has shrunk by 73%, as per the Living Planet report, which came out last week. This is alarming, and not to forget that the climate crisis is further exacerbating the biodiversity crisis and vice versa. With our work with Animating the Carbon Cycle and this collaboration that we did from WWF Netherlands, with Dr. Schmitz and Carl from GRA, we try to build synergies. We try to remove these silos, at least, between the two crises that can support both policymakers as well as practitioners. It goes without saying that wildlife is an integral part of the ecosystem, but their role in climate mitigation and climate adaptation and resilience is underestimated. It has been mentioned before that it is indeed true that in the climate negotiations, I work on climate adaptation, international climate policy. Animals are hardly mentioned. We do have language in the adaptation text, which made it to the text of the global stocktake, where we have ecosystems and biodiversity in the last year. Wildlife may be referred to as a litmus test to see how nature is doing. Key species of wildlife plays a vital role in their interaction within their respective ecosystems, as has been presented before. The carbon model that was developed by Dr. Schmitz, which also has been presented before, helps to calculate the carbon sequestration ability of wildlife species through their interactions within their ecosystem. Ecosystem functioning contributes to its adaptive capacity and ultimately to its resilience as well. So not only climate mitigation, but also climate adaptation and resilience in times of changes or shocks. And in this case, it's climate change and the climate crisis. We must remember that adaptive capacity and resilience of human systems is highly dependent on ecological systems. We worked on this project with Yale University and Global Rewilding Alliance in understanding the carbon capture and storage potential of key wildlife species in their ecosystems in 2 study areas. The conservative results and/or estimates goes on to demonstrate that wild animals can supercharge the ability of ecosystems to draw down atmospheric carbon. Next slide, please. The European bison became extinct in the wild in 1927 with only 54 individuals surviving in zoological facilities. Thanks to breeding and reintroduction, over 7,000 bison now roam freely across Europe. We started a small project to test the carbon model in the Carpathian Mountains, focusing on the bisons. Next slide, please. In a rewilding area of the southwestern Romanian Carpathians, over 170 bisons mainly utilize open habitats. Our study has revealed that positive effect of bison on carbon storage. Bisons not only contribute to maintaining the open habitats, but also play a significant role in climate change mitigation, also resilience. Next slide, please. As per our project, the modeling reveals that rewilding European bison to the Tarcu Mountains area could result in an estimated 9.8 times, almost 10 times higher carbon capture and storage in grasslands and open canopy forest gaps compared to their absence in the area. It is estimated that a total of 54,310 tons of carbon could be captured and stored annually in the 48.55 square kilometer grassland open canopy forests, which is the study area, because of the presence of bisons in the ecosystem. This is the start of understanding the complex but crucial dynamics between wildlife and climate change. As we inch closer to the COPs this year, and with a joint statement by the CBD COP15 and UNFCCC COP28 presidencies on climate, nature, and people about working on biodiversity and climate together, there is a momentum now for research, practice, and policy stakeholders to delve deeper into this topic and break the silos that maintain the gap between the two crises, which are essentially one crisis with two names. Nature contributes 53 to 54% in absorbing carbon from the atmosphere. It is important to incorporate increased numerical results of how conservation and protection of wildlife within their ecosystems are also a nature-based or natural climate solution, as they contribute to ecosystem carbon capture and storage. Corridors, conservation and protection strategies should increasingly be reported and included in countries' nationally determined contributions, national adaptation plans, and national biodiversity strategy and action plans in alignment with one another, which is at a national level, but also form the basis of discussion and negotiations at the international conventions. The climate crisis is not one of extreme weather events only. It's deeply rooted in the historical relationship that humankind has fostered with its natural environment and with itself. Meeting the goal of the Paris Agreement and other regional goals, such as the European Green Deal, paves the pathways to achieve a climate-resilient world. We need a package of policies as well as solutions to limit temperature increase to 1.5. And it starts with sustained, irreversible policies and solutions to limit temperature increase to 1.5. Irreversible policies, that support nature restoration, climate adaptation, and mitigation in a synergistic manner, which is very important, and collaborating with multiple stakeholders, especially those who live near these ecosystems and directly rely on them for their livelihoods. I will stop there. Thank you.
Thank you, Mahin. 170 bisons draw down an additional 50,000 tons of carbon per year on an area of 48 square kilometers of grassland. This is quite impressive, and it gives us an indication of the possibilities of restoring ecosystems and wildlife populations. Our next speaker is Simon Edison from the International Fund for Animal Welfare, IFO. He will dive into how governments can integrate wildlife into their nationally determined contributions. Simon, over to you.
Thank you, Carl. Good morning, good afternoon, and good evening to all on this call. My name's Simon Addison. I'm the Climate Change Advisor at the International Fund for Animal Welfare. And for the past couple of years, we've been working together with our friends at the Global Rewilding Alliance and others to think about how countries, national governments in particular, could take action to integrate animating the carbon cycle into their climate action planning and operations at national and local levels. And given that next year, in 2025, is the year that all countries are expected to submit their new nationally determined contributions, including all European countries, under their obligations to the UNFCCC, we have been looking at what can policymakers do to get wildlife into their NDCs and to bring animating the carbon cycle into climate action planning. So next slide, please, Peter. So as I've just mentioned, why 2025? Well, the UNFCCC is asking countries to submit what they're calling their NDCs 3.0. And we believe this is an excellent opportunity for all countries to include contributions of wild animals and conservation to both climate change mitigation, which we've been hearing about, but also the important aspects of wildlife conservation and rewilding that contribute to climate change adaptation. Next slide, please. And why should countries include wild animals in their NDCs? We've already heard most of this. We don't really need to go over it again. But in terms of mitigation, as we've just heard, healthy wildlife populations can help ecosystems store more carbon. Balanced ecosystems that have healthy wildlife populations provide critical ecosystem services for people and nature that support climate mitigation. But wild animals also themselves face significant risks from climate change. So by integrating wildlife protection into our mitigation plans, we can create a virtuous circle whereby we're leveraging this power that animals have to supercharge carbon capture and sequestration and storage, and then to support them to do that by creating the conditions that can enable them to thrive in a way that is resilient to climate change. Next slide. Then in terms of resilience and adaptation, I think it's clear across Europe as well as in the other continents we work in that biodiverse ecosystems strengthen the resilience of landscapes and the delivery of ecosystem services that people and animals depend upon to be resilient to climate change and other risks. So building climate resilient landscapes can support animals to deliver the benefits that they provide to carbon sequestration and ecosystem health. But they can also enable people and economies to be more resilient to climate change. The wildlife economy across Europe delivers significant economic benefits to communities and national economies, and supporting climate resilient development and climate adaptation at local and national levels. And this can be expanded. And by protecting and expanding wildlife and wild animal populations to historic levels, countries can increase the economic benefits that come to their citizens. And that can in turn support broader resilience of households and communities. So we're looking at two aspects here: that supporting wildlife conservation, the protection, restoration and effective management of their populations, and rewilding can deliver multiple benefits for nature, the climate, and for people in an integrated way. The next slide, please. But wildlife are missing from nationally determined contributions. We conducted some analysis specifically on African countries and those of least developed countries, where we, including many of the mega diverse countries, where we think that there is a massive potential to leverage wildlife conservation and biodiversity conservation more broadly for climate action. What we found is that the vast majority of countries simply don't recognize or integrate wild animals and wild animal conservation into their climate action plans. In fact, 60% of African countries and other least developed countries have not included wildlife conservation at all. But this is a missed opportunity for all countries to supercharge climate action plans through wildlife conservation. Next. So what can countries do? I think the first step is really to acknowledge what we've been listening to already this afternoon, which is to acknowledge that wildlife conservation and rewilding are powerful means for accelerating carbon sequestration and supporting adaptation and resilience. But we then, at national level, need to estimate the contribution that wildlife conservation and rewilding can make to mitigation and adaptation in each country, using the kinds of modeling that we've been hearing about from our colleagues at Yale and WWF and from Fabio. So we can then, on the basis of those estimates, start to include trophic rewilding, wildlife conservation, and the wildlife economy in nationally determined contributions, making them core pillars for delivering on the climate goals that we need to meet under the terms of the UNFCCC, but doing so in a way that can also support us to deliver on national obligations under the Convention on Biological Diversity, and we're having the COP16 for that soon. So building synergy between biodiversity protection and climate action plans can be done by following these steps. Fourthly, building on an action plan, we would need to then cost what wildlife-related climate actions look like. What kind of finance do we need to generate? What kind of investment do we need to make to raise, to implement these climate-relevant actions within the wildlife sector? And then use our NDCs to raise carbon and climate finance that can be used to supercharge wildlife conservation and rewilding. Next. So with all that in mind, we've elaborated 10 guidelines for integrating wildlife into NDCs, and I'll just run through them quickly. The first, as I've mentioned, is to establish that contribution that key species and wildlife habitats can make to climate change mitigation and adaptation in each country. This requires engagement with members of the scientific community, particularly people like Professor Schmitz and Professor Fabio Bergazzi, to work together with officials within national departments for wildlife conservation and climate change to work out where these key species are, what are your hotspots, which ecosystems need to be prioritized for protection and rewilding in order to capture and leverage this potential of important species. Next slide. We also then need to identify the major risks to those wildlife populations and ecosystems, particularly because as climate change, land use change, other forms of biodiversity loss are undermining the ability of ecosystems and of wild animal populations to support these natural climate solutions. We've just seen a paper come out in the past couple of days that is showing that globally, the carbon sequestration potential of natural ecosystems is flatlining. So what can we do to support those ecosystems and animal populations to minimize the risks that they face so that this potential can be delivered? Next slide, please. Thirdly, each country could specify the wildlife species and ecosystems that they see as priorities, those that they seek to protect and restore as part of their national climate action plans. And you can see here on the map just a selection of the key species globally that reside in hotspots where Professor Schmitz and others have identified potential for carbon sequestration support in animating the carbon cycle. Next slide. We can then, in the NDC, describe the plans that we have for including wildlife-nature interactions in the national greenhouse gas inventories. So looking at what are the current rates of greenhouse gas emissions in areas that are experiencing biodiversity loss and deforestation, and what benefits would we get in the greenhouse gas inventory from supporting wildlife populations to be protected and to grow. Next slide. Each country can then set high-level targets based on all of that data for the delivery of climate change mitigation and adaptation through conservation and rewilding as part of its NDC. Next slide. And can list specific actions. Then step 6, listing the specific actions that each country will take to deliver wildlife and climate targets through animating the carbon cycle. Next slide. Based on that action plan, it would be necessary to cost out the financial support that's required to implement wildlife-related NDC actions in a way that links climate action and wildlife and biodiversity conservation. This can often be challenging because the biodiversity conservation and climate action budgets sit in different parts of national governments. So building an integrated and holistic approach that brings a whole of government and whole of society approach in defining the costs and action plans will be quite important. Next slide. Each country can also outline the capacity support and technology transfer that it would be required to implement these wildlife-based NDC actions. And this is particularly important, we find, for countries of ours in the global south that face greater capacity and technology constraints than those found in Europe. But I think it's equally important to recognize that much of the modeling that we've been hearing about, much of the estimation of the relationship between wildlife populations, rewilding processes, and carbon capture and storage are nascent. And these are probably capacities that are required in departments across government, across Europe. Next slide. Then it's necessary to explain how each country will align its institutional arrangements for managing this integrated response between climate change and biodiversity loss. So looking at the institutional frameworks, institutional arrangements, departments and ministries that work together, how they work and how they can work in a more joined up fashion. Next slide. And similarly, to then identify the policy linkages between the NDC and other domestic and international policy frameworks for the protection of wildlife and biodiversity. I've already mentioned that this year we have 2 separate COPs, one for biodiversity, one for climate change. Often those involved in these COPs working on these conventions don't engage with one another closely. Similarly, at the national government level, there may be a lack of coordination and collaboration. We can use an NDC in 2025 to build wildlife and biodiversity conservation into climate action plans, and similarly align then with national biodiversity action and strategic plans under the Convention on Biological Diversity. Next slide. This is all captured in a set of wildlife guidelines for NDCs that I4 is launching at the beginning of COP16 next week in Cali. Watch out for that. There will be information going around online through social media and otherwise through our friends at the GRA and through I4. So this will provide a detailed outline of how each country can apply these guidelines. And we're also very happy to provide advice and to have a call with anyone who wants more information. Thank you.
Thank you, Simon. This was a pretty comprehensive and well thought through roadmap. I would like to mention that IFO and the Global Rewilding Alliance had a couple of webinars over the last 10 days with policymakers from Africa and the Middle East, and there was a considerable interest from these policymakers on the Yale model to quantify the net carbon impact of wildlife. We are now moving to the Q&A. As Simon had the last presentation, we have asked Alistair Scott, the Communications and Outreach Director from the Global Rewilding Alliance, to take over the Q&A session. Alistair, over to you.
As Carl says, I'm Alistair Scott. I'm Director for Communications and Outreach at the Global Rewilding Alliance. Just to remind you that please put your questions for the speakers in the chat. I'll be keeping an eye on that. And also I've put the address for the Animating the Carbon Cycle website in the chat as well, just so you can go and cut and paste that for looking at that later. It's a really beautiful site, and it brings together at least 60 references with some of the foundational science and evidence and also early sort of policy initiatives in this area. So it's a really brilliant resource. You can sign up and receive updates and so on there. So in the absence of any questions yet from the chat, I have a few of my own. The first one for the researchers, really, for Oz and Fabio. We often hear, you know, we can do more research, Oz and Fabio. So, and we can always do more research, of course. You know, there's a massive and complicated field. But how secure is our existing knowledge, do you feel, as a basis for policy action?
I think it's quite secure because people have been, you know, doing ecosystem-based measurements for quite some time. So we do have good, strong baseline empirical understanding, not just modeling, but empirical understanding of what, you know, the scope of ecosystems in terms of their carbon capture can be, sort of in terms of a baseline. And so when we do our modeling, we can actually validate it, you know, like the control conditions without animals. We can actually use the modeling to validate against what we've already seen measured in the absence of animals. And a lot of times our models are quite convergent on what we see empirically. So that boosts confidence that, you know, the effects of the animals are reasonable first approximations of what we might expect. Plus, you know, we're using well-studied mechanisms of animal impacts. You know, their trampling effects. We know what they do. When they feed, we know what they do. When they defecate, we're getting a better handle on what we do. Although, you know, watching animals defecate and urinate is not a sexy thing in wildlife ecology, but that's probably the most important thing to measure. But I'm pretty confident that we have a good foundation that we can build on.
Would you say the same, Fabio?
I agree, and you know, the ironic thing is that sometimes we do modeling studies and we are criticized, saying, "No, it's just a model," and then, you know, a few years later, there's some measurements in the field that confirm that the model is quite close to a reality. So these two things go hand in hand, and we've been doing these kind of experiments in science for a few decades now, and frankly, we can, I mean, the evidence is mounting very quickly. Look at the fishing, all the fishing studies in the last, all the studies on the effects of fishing on carbon sequestration in the ocean. They're just one every few months. And, you know, first it was just the tuna, then all the fish, then mesopelagic fish, now the squids, then, you know, whales. And it just seems logical that a system that's been functioning a certain way for thousands and thousands of years, if it's modified, it will change drastically. And so we can't really wait to have the last science, you know if it's just 1 or 2 or 5%. We have evidence. We can start already with that evidence and create better functioning ecosystems that are actually more resilient to climate change because and all these pressures. So it's not just the carbon itself, is that if we have resilient ecosystem, they can take the hit and for what's coming and what's coming after. You know, we are not stopping the trajectory of climate change. And I think we have plenty of evidence for many ecosystems already and what we can do in terms of on the ground, in terms of management and restoration.
That's wonderful. So it's very refreshing to find research, as you say. We do not need yet more research before proceeding and acting. You know, I get a sense of both of you that we need to act, and we can continue to calibrate and improve the knowledge as we go. So that's wonderful. And while we're speaking to both of you, we have a question from Adam Devonish saying, I wonder what your thoughts are to the Duval et al. Paper in Nature. I'm not sure it was a paper. I think it was a commentary or a question or something that raised some concerns about the carbonization of animals as a carbon solution. Oz.
Yeah, it's ironic because those authors have written other papers where they also argue for carbonization of animals, so they're contradicting themselves a bit. But I think the way to interpret the article, it's really, let's be cautious about the financing of it. I think, you know, they're on the side where we need more science, we need to move forward. And some of the claims they make in the paper about how long it would take for animals to actually have an effect are not supported by emerging science right now. You know, restoring animals, you know, even in the Serengeti, when the wildebeest came back, within 20 years, we've got the Serengeti going from a carbon source to a carbon sink in 20 years by rebuilding animals from 300,000 to over 1.2 million animals. That's quick. In parts of Czechoslovakia, they've already rewilded bison. And in the course of 6 years, they can already measure differences in soil carbon content between places where the bison are and where they aren't. And so, you know, the convention is that it takes 100 years to build up carbon. Well, these data are now showing that it happens faster. And so I think a lot of their arguments aren't based on the latest science. And scientifically, it's always valuable to have people question, you know, so we don't go headlong into doing something that might in the end not prove to be valuable. So, you know, they're trying to be precautious, but ultimately what they're arguing for is disentangling wildlife conservation from climate solutions. And as I've shown you in the table, in terms of protecting ecosystems, avoiding emissions, we need to conserve a lot of those animals, and a lot of them face existential threats. Wolves are being culled, right? Sea otters are threatened with culling to protect abalone fisheries. They want to build a highway across the Serengeti, which would cut off the migration of the wildebeest and change things. So we actually need to really link these two together more effectively, or else we're going to let nature go and then have climate problems.
Yes, that's wonderful. Thank you, Oz. And you touch upon something there that we see time and again from our 200 plus partners in the Global Rewilding Alliance, is that is just how quickly ecosystems can recover. it's amazing. You know, we have story after story of wildlife populations recovering so quickly, and species that were thought to be extinct in certain countries or areas suddenly reappearing when rewilding takes place. So there is a certain sort of magic to this that is also hard to pin down. A second question I have is about an objection to rewilding that we sometimes come across with respect to conflicts with other land uses, such as food production. So could I ask maybe Maheen, possibly Simon, where did all the land come from, for example, for the bison in Romania? So, you know, does this objection about conflict with land uses stack up? Maheen, would you like to?
Maybe I can give a head start. I was just writing on the chat that I'm about to be kicked out from the office because they close gates in like half an hour.
Oh,
So,
no.
but maybe something Oz can also talk about with regards to, it really depends on the area, it really depends on the ecosystem itself. So the Romania, for example, the Carpathian Mountains, it's not as densely populated as opposed to another ecosystem which might be densely populated and therefore have coexistence issues or issues in terms of conflict with communities living there. So I think it's not it's not a one size fits all argument. It really depends from ecosystem to ecosystem. It really depends on the economic situation of the country, policies of the country, which is why we're having this webinar, I think, is that and I wrote in the chat as well about this rewilding issue that, of course, this is science, right? We will always have many different many sort of opinions on this, but it has to be science-based. And the papers that we saw today, they are all science-based, they are estimates, and we have to keep up with this narrative and work on the science going forward, because we have to build on the synergies. Alistair, I know I'm going on a bit of a tangent, but before I get kicked out, I want to say one more thing, and before I leave, is that this work is important because, and what you were asking before about there being more research and more science to back up these arguments and build a coherent narrative across this very much siloed sectors that we are working on. It's important to also do joint advocacy in policy. So they all feed in each other, right? So we have this research, we are presenting the numbers, we're talking to policymakers, we're doing advocacy to sort of make the links, So it's really important for it to also work on the other way. So once we are identifying these elements in science and talking to policymakers and practitioners, and like WWF Netherlands, we grounded this model. We implemented the application of the model in 2 of our sites, and that's why I'm here talking about the case studies. This provides a leeway to start talking about the policy, science, and practice nexus. So I really just wanted to add that, and I hope I got started on your question, and I'll stop there. Thank you.
Yes, that's perfect. Thank you. Simon, do you have a few short thoughts to add, and then we'll move?
Yes, I mean, I note the concern, and this does come up quite often in talking about this issue in terms of the potential for negative trade-offs between rewilding or even just considering wild animal conservation as something that could be a valuable contributor to addressing climate goals and food security or food production. I think the first thing is to note that, given where we are globally in terms of the climate and biodiversity crises, securing, protecting, and restoring biodiversity is one of the most important things that we can do to maintain a hospitable environment on the planet that supports food production in general.
Yes.
And in that sense, I think there tends to be a certain false equivalence between concern for food production and securing, let's say, natural ecosystem services that deliver benefits that go way beyond an immediate locality or landscape, for instance. So I'm thinking here in terms of the value that, say, the Amazon rainforest generates globally in terms of water production, in terms of its carbon sequestration potential, etc. We also should bear in mind the fact that, globally speaking, in terms of food production and supply, it greatly outstrips food consumption. The great problem that we have globally is a maldistribution of food that results in this bizarre and inequitable situation where we have significant levels of obesity in developed and some developing countries, and then high levels of malnutrition and low levels of access and availability to food in other places. The issue there is not that there is a trade-off between land availability for food production and the need for fostering and supporting wildlife and biodiversity conservation for other purposes. It's that we have a deeply inequitable and deeply problematic food system globally, and that cascades down to national and local levels. Addressing the challenges of the food system, I think, is what is really critical, whilst bearing in mind the fact that ecosystems deliver immense benefits for food production. There's been a comment here about the integration of animals into food production systems, thinking about the importance of that within permaculture systems, the need for the integration of animal biodiversity in agroforestry and agroecology systems. These are all the kinds of things that we need to be thinking about so that we're taking a more synergetic and syntropic approach to agriculture and food production.
That's wonderful. Thank you, Simon. So we've come to the end of the allotted time for the Q&A. I see more chat coming up in the chat, so that's really good. Some really good questions. Sorry we didn't have time to address all of them. Over to you, Carl, to introduce our final speaker.
Thank you, Alistair. And now we come to the last point. We have asked a member of the European Parliament to listen to all those presentations and to give us his closing comments on what he thinks the value of this debate would be for the legislations in the European Parliament. And I welcome Michael Wiesig, an MEP, a nature-friendly MEP, to give us the closing comments from a policymaker's point of view. Michael, the floor is yours.
Yeah. All right. So first of all, thank you very much for all the organizers and the speakers for this splendid event. It was really a pleasure to listen to your presentations and to find out so many new things. And it's quite a privilege to have a closing remarks on this event. So where to start? I really was very delighted to see and to be presented actually the growing body of scientific empirical evidence that proves very clearly that wildlife protection and restoration is not at that cost, not at all. And instead, it really holds a great promise to address challenges at the same, but the two main challenges at the same time: the biodiversity crisis, which frankly was quite settled in this regard, and the climate agenda as well, which to many of us might be very new. Maybe just to express my perspective on this and maybe the problematic moments that I perceive, you all have been talking about rewilding, which frankly is not a term that we currently use in EU policy, which is our fault, as I would stress it. But at the same time, I have to say that the essence of rewilding is very well embedded in the context of nature restoration, which I'm very happy about, and especially with regard to agricultural landscape, wetlands, river and sea restoration. But also you might find it in some specific regional contexts and implementation within forest and urban areas. So I think we can really work on this idea of rewilding despite not being allowed to mention it, so there's a chance for improvement. What I really appreciate about this event is that the wildlife was treated or considered in positive manner in this event, which is a perspective of which we don't hear that often from the side of decision makers. Quite contrary, and especially in recent times, there has been quite a strong shift towards treating is rather negative. And just to stress one instance, you probably all are well aware about the story of wolf in Europe, but a huge success story of its recovery is currently causing a huge rise of anti-nature narratives in the European Union. This is, however, a very sad story. The attack on wolf is really not being funded by facts, nor by good science. In that regard, it has to be treated as a sole populism. But at the same time, it is a good lesson to be learned, and that is that the restoration of wildlife is usually not enough, and we also need to restore the acceptance of the wildlife by the public, and that the issue is much broader and interlinked with culture, economic, and political situation. It's never enough, or there is never enough of explaining towards public, there is never enough of showing the good practice, and we simply do not have the comfort to rest. It's a never-ending struggle. We have heard how wild animals enable intact ecosystems to draw vast amounts of carbon. The potential area for these effects to take place were well presented. The question, however, is how much of this space are we willing to devote to wildlife and carbon animation? I don't think that current political willingness for these activities is super immense, in particular on European level. So a lot of effort is ahead of us, and we need to act fast. We have heard that the feedback effects the wild animals provide us with are disproportionately larger than we would expect based on their biomass. In other words, our ecosystems have always been operating also due to the presence of huge mass of large animals. And these ecosystems cannot work properly and provide us with necessary ecosystem services otherwise. Indeed, a forest with elephants and without elephants, these are really two different forests, with the latter being less diverse and less resilient. We should really be able to exploit the fact that wildlife restoration through rewilding can make substantial contribution to countries' NDCs under the Paris Agreement. And as we move towards COP16, we are seeing more governments evolving their plans and policies in this way. So let's really stress those positive examples of good practice. It is very exciting development to see rewilding organizations around the world working with national governments to adopt this approach. And I would really like to thank you, all of you, for your huge and very useful effort. And just to conclude, I hope you all were inspired by this webinar the same way as I was, and I look forward to seeing more policymakers engaging with these exciting and evidence-based ideas. Thank you. It's really about life.
Thank you. Thank you, Michael. Thank you, Michael. So I think we're now at the end. Just maybe one comment, there's not a real clear line between restoration and rewilding. What we always say is all rewilding is restoration, but not all restoration is rewilding. So that's the way how we deal it. So we consider a little bit rewilding as the gold standard for restoration. Thanks, Michael. That was a very good closing comments. I thank everybody, all of our speakers, and I thank all the participants. I remind you, you're going to get a link for this recording, so you can actually view some of the presentations again. And there is a website devoted to ACC, which is animatingcarbon.earth. There you will find a lot more information. I close this now, and thank you, everybody. Thanks for participating. Have a nice afternoon, morning, or whatever. Thank you. Bye-bye.